Bro.
Good evening, everyone. Today we will be presenting our project titled Predicting Student Academic Performance Using Feature Engineering. So, in many schools, identifying students who are struggling happens too late. Typically, teachers only realize a student is at risk after final exams are done and the final grades are dropped. So, this delay reduces the chances of timely support and increases the risk of long-term academic issues. We also found that the raw educational data sets contain many scattered features, some useful, some are not useful, making it difficult for the machine learning models to understand the actual academic behavior of the students. So the main aim of our project was to design a predictive model that can flag at risk students early using meaningful and well-engineered features. So we focused on three goals: to perform raw data into interpretable behavior-based features. The second one is to select only the most important predictors for clarity and accuracy, to train multiple learning models and choose the one that best identifies failing students. So, in short, we wanted a model that is accurate, ethical, and practically used for educators. So, when it comes to the approach, we worked with the UCA student performance dataset and created 9 composite features that represent student behavior, such as academic support, risk factor, total activity, and study efficiency. So after feature selection, we reduced the dataset to 14 high impacted features. We then trained different models like logistic regression, SVM, gradient boosting, and random forest. The random forest gives the strongest and most stable results, especially after hyperparameter tuning. So when it comes to our key outcomes of our project, our final model achieved 81.5% accuracy and 0.89% F1 score and 0.92 recall, which means it correctly identifies most students who are actually at the risk of failing. Instead of just focusing on traditional accuracy, we emphasized recall because catching failing students early in the real is the real purpose of this particular system. So the project successfully shows that the feature engineering can significantly improve educational prediction models and make them more accountable for real world use. So when it comes to the future work that we can have for this particular project, so we can expand the data set with more schools for better generalization, build an interactive dashboard for teachers to upload data instantly to get predictions, add time-based data like monthly grades, attendance trends to make predictions even more accurate. So evaluate fairness to ensure that model performs equally well for all groups of students. So these are the future works that we can rely on. In further will be continued by my friend.
So, in our project, we used several important Python modules that helped us to complete machine learning systems. So, one of the model we used is Pandas, which we use to load, clean, and pre-processing the dataset. While the other model is NumPy, which supported numerical operations and calculations. So for the visualization of the code, we used Matplotlib and Seaborn to create graphs, and that helps us to understand patterns such as grade distributions and correlations. So the most important module was Skikit-learn, which provided tools for pre-processing and encoding, feature selections, and training various machine model learning models for evaluating performance and turning hyperparameters. So these models was unable to develop an efficient and accurate predictive pipeline. So we by using these models, we achieved several major outcomes in our project. We were able to clean and prepare the dataset efficiently, and the social activity, visualize the behavior patterns clearly. Feature selection methods helps us to identify the most influential predictors. By comparing their performance accurately, grid-set CV helped us to optimize the random forest to achieve strong results. So overall, these models transformed the raw data into an effective and interpretable prediction model. So before using these models, building a project like this would have been extremely difficult and time consuming. Without pandas and numpy, even basic data cleaning, merging, and numerical calculations would require manual methods that are slow and error prone. Without visualization tools like Matplotlib and Seaborn, we would not understand the trends, patterns, or relationships within the datasets. So without scikit-learn, we could not perform encoding, scaling, or model training effectively. So without these models, the entire process would lack accuracy, structure, and efficiency, making reliable machine learning results nearly impossible. So the rest will continue.
Coming to our project, the main part is the results. So our main goal is to catch the risk of the students who got a failure in exams. So the main task is to optimize the random forest achieved around the 92% recall, meaning it defined almost all students who actually failed. So we also got a high F1 score of about 0.89, which shows that the model balances precision and recall. So overall, the model is both sensitive. And coming to the influential predictors, from future importance, we found that the academic history and the aspirations are stronger predictions than pure economical variables. Some of the top features include a number of past failures and has failures flag, whether the student plans for higher education and the school type and the social activity level, which is one of our engineered features. This gives teachers the accurate results of a student. And coming to common challenges, we also address some like the AutoML is better. It can give a good accuracy, but manual feature engineering gives unpredictability, which educators need to be understand when a student is at high risk of failure. And we achieved some of the features like the audited one and the sensitive variables and built behavior based indices like the risk factor index. And the data set is also too small, even with 649 students. Our cross validation is stable, and the effect sizes are also large enough to be meaningful in a types school level settings. So finally, the model is not just a tired intervention. Students with high social activity risk can get time management counseling. Students with past failures can also be placed into mentoring programs. In last, I would say like it provided us with a better understanding of failures, so it can help the student to prevent it from getting risk. So the rest of the part will be continued by my friend.
For now, like we want to go to the code explanation. First, in Sylvan, we do like importing libraries and loading the dataset. Important in that we has imported the pandas, numpy, matplotlib, seaborn, and sklearn. Like the tools are we are imported, and which is needed for the pre-processing and models and fetching the UCI student dataset using fetch UCI and combine futures and the targeted grade like G3 into the one data frame called DF. This is the dataset we used in our project. And in the cell 2, we use the basic dataset exploration and understanding, printed the shape of the dataset and size of the dataset and missing values like null values like that, and user describe to understand the distributions of numeric features uh, like that, and clean the dataset uh, with null values with zeros or ones with like that. Hmm. This is the basic strategies like in we use in zeros or ones we use this is the null value we use uh, a clean distributions for this we got the zeros, and in third cell data visualization for understanding the creating target and first values, create new binary label pass where G3 is greater than or equal to 10, which pass is else fail. Calculated the pass or fail distribution to show the imbalance and plotted the basic graphs to see the target behavior like this. This is the final grades of this mm, of this. And in cell created the engineering futures like alcohol consumption, parent education, support scores, social anxiety, etc., and added the binary flags like failures and high absence. Build compose includes like high risk factors and support factors for rich parents like that. But this is the creation of the future engineering for our project. And this is the new futures of statistics for alcohol consumption. This one is the alcohol consumption and parents education, academic support and social anxiety. This one is how the student efficient in the studies and his failures, his absence, risk factors. This is the support factors. After that, data pre-processing in cell 5, splitting the data into the futures like x is a future value and y is a target value. Applied one hot encoding to target and to categorical columns and scaling to the numerical columns. Where this is the one. And combined everything into a clean and pre-processing matrix ready for the modeling. This is the data pre-processing, and this is the categorical column like school, sex, address, font size like that, and this is the numerical column like age, fedu, and travel time, study time, failures like that. We applied the one hot encoding for this for the shape of 649 and 49, applying the standard scaling to numerical features for the pre-processing the data for completion. This is and final feature to set the shape is 649 and 14. This is the new futures with the target values. After that, future selection. Uh, Splitting the data into training and validation and testing sets using random forest importance and select k-based and finding the strong futures, took the intersection of the both methods and reduced it to the final selected future set and plotted the graph for that pre-processing for training and testing the data for and select k-based for select k-based scores. This is the future selection of training data set and validation set. This is the test set and random forest importance. This is the for has failures 0.09 like that we printed this one. For the above values, this is the graph. After that, the model selection. Trained multiple models like logistic regression, random forest, support vector mission, gradient boosting for the calculation of the how much of the time they travel to the school and what is the parents' education and what how much effort they put in the study. For that calculation, we use these models like logistic regression and random forest. After that, measured accuracy, the perception, recall, F1 score, and ROC, AUC for the each element of this. Found random forest performing best overall, like especially on the recall and F1 scores. This is the scores. Training of the logistic regression. This is the accuracy, F1 score prediction for everything. We print the accuracy and F1 score. These all are we printing. And model comparison. This is the model comparison for random forest. Yeah, this comparison for accuracy, F1 score, ROC, and precision recall. This is the graphs for the everything about that thing. Sorry. After that, model optimization. Trained multiple model. Created a random forest parameters, a tree's depth, leaf size like that, and Arraign grid search, RV, and cross validation for F1 as the scrolling metrics. I reviewed the best performing parameter combined for the final model. This is the model optimization. After the model optimization training hyperparameter, this is the output for that. After final test evaluation, like final model evaluation, like evaluated the optimization random forest on the test set, reported metrics, accuracy, precision, like that way, and plotted the confusion matrix for ROC curve and precision recall curve for the deeper analysis. Okay, like we should understand the deeper for the accuracy, how much accuracy they are putting. This is the confusion matrix. Actual fail is 5 and 15, and actual pass is the 9 and 101. And this is the outputs for the final test evaluation. After in fourth cell we implemented the future engineering. For that we do analysis of the future engineering, extracted the future importance from the trained random forest model, spotted and plotted the graph from top of the predictions, explained which futures matter most for the prediction student failure, and we printed the for how much the student will fail and most common failures in the students. This is the graph. This is the failure percentage. First one is a failure percentage and failures and higher. After that, deployment prediction, model deployment preparation. I was summarized the whole the new student data as input and applies the same pre-processing steps like encoding plus scaling. After that, returns the predicted failure risk from the trained random forest model. For this is the output. In the final, summarized the whole pipeline as a dataset loading to model evaluation, printed engineering to future count, select future counts, and final performance. Highlighted the best model and influenced the futures. This is the final accuracies for accuracy F1 score, ROC, AUC, and precision for the recall. We use the most important predictions for these five of these things. And this is the graph for the final model metrics. Thank you.